Alright, so question 8 is similar to previous questions and question 10. So if we have a look at it, it does start with y equals log of x plus square root x squared minus a squared, and it asks us to differentiate and simplify. So if I have a look at that, y equals log of x plus square root x squared minus a squared. Now, if you differentiate log, so dy dx, remember it's f dash of x on f of x, where this bit here is our f of x. So f dash of x on f of x, I know the bottom is going to be that. And the top, whoops, it's a minus. So the top, when I differentiate x, and that is not squared either. Alright, when I differentiate x, I get 1 plus when I differentiate, now you might want to just do this separately. So this part is x squared minus a squared to the power of a half. So if I differentiate that with respect to x, it's a chain rule, so I need that part, the outside part, times the derivative of the inside part. And you'll see the 2 and the half cancel. So you've got x on the square root of x squared minus a squared. So that part goes here. X on the square root of x squared minus a squared. Now, if I want to simplify, I don't want a fraction in a fraction. So what I might do is multiply both top and bottom by x squared minus a squared. So I'm really multiplying by 1. But what that gives us is at the top, so 1 times the third is the third, and then plus x on the third times the third just gives us x. At the bottom, I'm going to multiply it, but I'm going to keep it separate. I'm not going to multiply it through. So I get that, and I'll just put this here. So you'll note that the top and the bottom are we've got some common factors. So I can actually cancel that and that because they're common factors. And what's left is just 1 on the square root of x squared minus a squared. So if the derivative of y gives me 1 on the square root of x squared minus a squared, then the integral of 1 on square root of x squared minus a squared with respect to x must go back to the y, which is log of x plus square root of x squared minus a squared, and just remember it's plus c. Alright, so hence there's our formula for b. Now it says use this formula. Okay, so you just get a bit of room. So we need to use this formula. Well, if we put the part 1 straight in the formula, you can see that it's going to equal log of x plus, so you're just putting it kind of back in, plus c. So that's easy enough. So it's putting straight into this as this is your formula. If you've got a definite integral here, so same, whoops, dx. So putting it in that formula, but now it's a definite integral. We've got x plus the square root of x squared minus 4, if you can read that, and root 5 and 3 here. Alright, so if we put that, sub that in, we've got our first log. We've got, in our square root, we've got a 3 squared, so a 9 minus 4, which is a 5. So here we've got 3 plus root 5 minus the log of, now I'm putting root 5 in. Root 5 squared is 5, 5 minus 4, so we've got square root of 1, which we know is just 1. Using log laws, you can see that that's going to be this over this. Alright, we could simplify that if we rationalize that denominator. So if I just do that somewhere else, so I'm going to just rub this off. So we've got some room over here. Alright, so if you think of rationalizing this, we can just simplify it a little bit. So if we times that's 5 by 1 minus root 5 on 1 minus root 5, At the top, we are going to get a 3 minus a 5, and so that's a minus 2. And we're going to get a negative 3 root 5 and a positive root 5, which is minus 2 root 5. You can do this yourselves. At the bottom, we've got difference of 2 squared, so we've got 1 minus 5. So really, here we've got minus 4 on the bottom. So I can actually divide both top and bottom by negative 2. I get a 1 plus root 2 over 2. So this actually, if I simplify it, is log of 1 plus root 5 on 2. There we go.